Hi everyone, good morning. I'm Akshay and welcome to the TechCraft YouTube channel and welcome to the System Design Series lecture number 2. In this lecture number 2, we will discuss one more important thing which is very important in client server architecture. In lecture number 1, we have discussed about how client, server and DNS talk to each other. See, in lecture number 1, we have discussed how this client, server and DNS talk to each other. But in today's lecture, we will discuss about something more important is called as data. Data. So what is data? Data means anything like text, images, video, audio, speech. This comes under data. So why data is important? Let's say you have visited a website. Let's say Amazon.com. This is a website called as Amazon. Let's say this is Amazon website. Okay. Amazon. So let's say you want to create an account in Amazon. So you fill your credentials like name, uh, address, phone number, door number, and your age, your email address, and all these credentials, right? So after filling all these details, there is a button at end. It's called a submit button. So what happens when you click on this submit button means after filling all the credentials like name, address, mail, your phone number, everything, after filling all these details, when you click on the submit button, where this credential goes, right? Question yourself where this credential goes. Every company maintains a database. Now after clicking on this button, these details will be stored in the company's database. So here we have heard a new term called as database. What is data? Data, if you have cleared what is data, data means anything like text, images, audio, videos calls data. So clear. Now what is database? See, database means many books and many blogs have different definitions. But what database means? Collection of related information. Once again, collection of related information. See, generally there are two types of databases: relational, non-relational. These relational databases are also called as SQL databases, and non-relational databases are also called as NoSQL databases. So, but I have stopped what happens after clicking on the submit button, right? I will tell you. When you click on the submit button, the data goes goes to the company's database and filled in the form of tables like, see, sorry. So in this way, your name is stored here, your address, your email, your phone number, your door number, etc. All these details will be filled in this database. So relational databases store data in the form of tables. See, examples of relational databases are MySQL, Postgres, and Oracle. These are comes under relational databases. Here these companies are storing the data in the form of tables, right? Now there are other companies like Instagram and Facebook stores in the form of objects like this. I think you have not understand why what I have drawn here. Let me erase. Up to now, you have understood what happens after clicking on that submit button. Your data will be uh, uh, inserted into this tables, like right now. Actually, this table is, think of, it's a database. Now let me tell you. I will tell you about non-relational databases. Non non-relational database. Non-relational database means the data does not stored in the form of tables. The data is does not stored in the form of tables. Then how it stored the values? The data is stored in the form of key value pairs and documents. See, how, means what? I didn't. You can think like I didn't understand what you have explained. See, in tables means you can understand the name, that email, all these things are stored. But in the form of documents means example of. I will tell you examples. Examples of non-relational databases are MongoDB and Cassandra, Amazon, uh, Dynamo. These comes under non-relational databases. Means actually these are not databases. These are database management systems. I will tell you what's the difference between database and database management systems. Just wait for a few minutes. And here, MongoDB, Cassandra, Amazon Dynamo are the database management systems. Here, the data is stored in the form of objects and key value pairs. See, I will give an example. See, object means anything in the form of this curly braces is called as an object. Here, let's say name Swami, comma, and again an object email some gmail.com, and again address something. See, everything anything stored in this format is a non-relational database. See that but the problem with this non-relational database is we cannot do join operations here. In what do you mean by join operations? Let us say in relational databases, let's say we have two tables. Imagine the tables as like Excel sheets. In Excel sheets, we have rows and columns, right? Think of there are rows and columns, and there are rows and columns. Join operation means we are combining these two tables. We're combining these two tables and forming a one table. But it's not easy to do. It's not possible to do join operations in non-relational databases. Means, let me take. Uh, okay, this is an object, some data, some data. This is an object, and again there is another object. It's not possible to do join operations for these two objects. So this is the problem with non-relational database. But non-relational databases are used by the companies like Instagram and Facebook. See, every day Instagram get lots of data like images, posts, feed, and friends everything. All this data is not in the form of uh, not in stored in the form of rows and columns. This is very big data, huge data. So this can be stored only in the form of this, only in the form of these objects. So most companies nowadays are shifted to these NoSQL databases. Now, now we will discuss about DBMS. What is DBMS? database management system. So database management system means it's a software, means it's a software containing set of programs. Using that software we can do CRUD operations on the database. Let DBMS. I have told you DBMS is sort of two types: relational database management systems like RDBMS and non-relational non-relational DBMS. Non-relational database management systems. In relational database management systems, using that relational database management systems, we can use four operations like create, update, read, and delete on databases. Means, let's say there is a database, there is a user database, like information about user in the form of tables. Let's say in this table we have information about 10 users. Let's say 1 2 3 and so on up to 10 users. We have information about 10 users in the form of rows and columns, right? This is non-relation sorry, this is relational database management systems. This is a database, user database. So using a RDBMS software like Oracle. Let's say you're using a Oracle software or MySQL or PostgreSQL. See the words PostgreSQL. See these three I have written here are called as DBMS software. See, database management system software. What we can do using these softwares, using this Oracle software or MySQL software or PostgreSQL software, we can do CRUD operations. What is meaning of CRUD? CRUD means C means create. We can create tables like this. We can create tables like this. A read means if for example if you want all the names of the users, let's say there is a column called name, you want all the names of the users in the database. So using we can read means getting the users information, getting the list of all the names of the users. Update, let's say somebody some address, let's say there is an address for that guy, address got changed, so we can update, we can let's say the second person address got changed, you can update by changing the address. Delete means we can delete a user, some, let's say somebody who don't want to uh, do shopping in Amazon, who don't want he wants to delete an account in a Amazon.com website. So after deleting an account, the user if, let's say the 10th user wants don't want an account in he wants to delete an account in Amazon, so this account will be deleted using this delete operation. So in our DBMS we can do this CRUD operations. Also we can do CRUD operations in non-relational databases also, like in like I will write the words like non-relational databases are MongoDB. See, MongoDB and Cassandra, these are non-relational databases. Then Amazon Dynamo, these are non-relational databases. Okay, up to now everything is clear. The next thing is, in lecture number 1 we have discussed about client and server, right? But we forgot about database. Now I will tell you. This is server, right? Client, request and response, everything is good. Okay, see what happens if we keep the database in the server. Is there any problem or not? Question yourself. So for that, we learn two new concepts called as vertical scaling and horizontal scaling. Vertical scaling and horizontal scaling. So what is vertical scaling and what is horizontal scaling, and why we need? So first of all, I will tell you what is scaling. Scaling means adding something to the servers or whatever it is. Adding Scaling means adding something. See, first I will tell you why we need vertical scaling and why we need horizontal scaling. See, mm, vertical scaling means adding more CPU power and more RAM to the single server. Means if you have a single server, for this single server you are adding more CPU, means unlimited CPU and unlimited RAM. So there are advantages and also there are disadvantages with it. Then what are the advantages is, let us say, this is the server. When requests are coming very less, let's say the requests are um, uh, like 10 requests per minute, or 20 requests per minute, means the requests are very less to the server, means the burden is very less to the server. Then this is okay, means one server is enough. But what happens if we want more requests are coming at the same time? Let's say 1,000 requests are coming at the same time, at the same moment. Let's say 1,000 requests are getting in a minute to the server. Then the server will give a response called as, with a status called 503, server is busy, right? I will give you an example for this. Let's say if a college is maintaining a single server during the semester results time, all the students are accessing the server at the same time, means they type their roll number and they click on the submit button to get the request. All the requests, means let's say there are mm, mm, let's say there are 600 students are accessing the server at the same time. Now let's say 600 students are accessing the server at the same time, the server cannot handle. So at that moment the server give you a response called as finally server is busy. So after 6 hours or after 7 hours, when the server is idle, then at that moment you can see your result. So it's a problem. So for there is a solution for that. The solution is horizontal scaling. So what is horizontal scaling? Horizontal scaling means adding more servers, means for a single application we are adding more servers. So this, by adding more servers, the request will be easily be transferred. Let's say there are 1,000 requests per minute. Now 200 requests will go to this, or next 200 requests, next 300 requests, they will share this request. So how sharing will happen, I will tell you within few minutes. So let me continue where I have stopped. I have stopped what happens when you keep database in a single server. What happens is, if you want to scale like horizontal scaling, if you, let's say, if for your application, initially there is a single server, and you have kept database, and the single server is have more CPU and more RAM. All you have told you what is the problem with the single server. So if you want to scale for horizontally, if you want to scale your web servers horizontally, there is a problem is, scaling with database is a big problem. You cannot scale with database. This is this is very big problem. It's not easy. It's not that much easy to scale servers with database. So what to do? Before that, I will tell you few limitations of vertical scaling and horizontal scaling. So what are that limitations? Let us say in vertical scaling, let, let's say, imagine this is the server. In this server, okay, we have added more CPU and more RAM, but the problem is single point of failure. means what happens if a server goes down? Then everything is waste of time, right? Means let's say it's a very important request is coming to the server. Let's say it's a payment request. Let's say in the few minutes ago we discussed about the semester results. Okay, it's just semester results. We can look at the results at night or midnight also, it's not a problem. Let's say the evening, yeah, let's say the results released in at evening, and we can see the results at midnight, it's not a problem. So what if the request is a payment request? Now that's a big problem, right? If a payment request is coming and the server is okay, we are maintaining only a single server, and in the single server uh, more CPU is there, more RAM is there. Even though, what happens if the server goes down? The server goes down, the payment then there is a failure in the payment, right? So here is called as a, here this is a SPOF, single point of failure. This is the problem with vertical scaling. Now, I will tell you an interesting point in horizontal scaling also. The interesting point is, we have discussed that when we have more requests, when we have a large number of users, we will use horizontal scaling. Let's say, 2000 users are coming, means 2000 users are 2000 requests are getting in a minute, in a minute. So, we will take a scenario, that is, what happens if 2000 requests are going to the same server? All 2000 requests are going to the same server and not utilizing these three servers. It's a big issue, right? Even though there are three servers, they are not the requests are not going to these three servers. The requests are going to only this server, and again the server is goes down. Server goes down, and you will not get the results. See, even though you have four servers, all the requests are going to only single server. Even though the remaining three servers are becoming idle, and they're paying for these servers. It's a big problem, right? So there is a solution for this horizontal scaling. The solution is load balancer. So what is load balancer? I will tell you. Yes. What is load balancer? See, when the request is before going to the server, first the request goes to the load balancer. Now this load balancer will distribute the requests to the servers. Let us say this is server 1, this is server 2. For the for the space constraints, I have drawn small servers. Imagine there are big servers. Okay. Now the load balancer, this is the load balancer. This load balancer will distribute the request to the servers. Let's say you're getting 1000 requests at the same time. Now this load balancer will distribute the request to the servers, 200, 300, and again remaining 500. So you can ask me one thing. uh, um, how load balancer means distribute this request? Load balancer is a program, means it's also a software. This software make you to distribute the request to the servers. So uh, there is one more doubt also. What happens if you get 1500 requests? At that moment, 200 requests, 300 requests, 500 requests are distributed, right? The remaining 500 requests are up to some specific amount of time the load balancer will handle. In that moment, the company can add an instance server, an instance server using some cloud services. Using cloud services like the Google Cloud. Using Google Cloud, they can add instantly that server. Now the load balancer distribute that remaining 500 requests to this remaining server. I will recap what I have explained you in this. See, this is your computer, and these are the servers. before sending directly the request to the web servers, the request is first goes to the load balancer. The load balancer will distribute the request to the these servers. Also, what happens if 1500 requests, more than 1000 requests came at the same, I mean, in the same minute, what we get, more than 1000 requests. If you get more than 1000 requests, the load balancer will handle for some moment of time. After that moment, the load balancer will distribute to the new server. Means in that moment, in that certain period of time, the company will add a new server so fast using a cloud services like Google Cloud, the famous Google Cloud service, or not only Google Cloud, other cloud services also. So this is how things will happen. This is how the requests are distributed to the servers. Now there is one more important point here is just a second. Hmm. One more important point here is your client, means our computer, access the load balancer with public IP address. Means, of course, let's say you have typed any website name, any, let's say google.com. You have typed google.com, but internally the IP address is goes to the load balancer. That's the public IP address. Even though uh, even though you have typed google.com, the public IP address of the google.com goes to the load balancer. Now the load balancer send the private IP addresses to the, it has its set of private IP addresses, send the private IP addresses to the servers. Means, the thing is, we cannot, the client, our client means us, we cannot access the servers directly. We cannot access the servers directly. So these are the points we have learned today, like about load balancers, about vertical scaling, about horizontal scaling, and why we should not keep the database inside the servers. What will I have already told you a few minutes ago. What is the problem? We cannot scale horizontally, scale the our system, our application, our servers, if we keep the database in the if we keep the database inside the server. So these are the things we have learned today. So I think video goes so long, so thank you, and we will discuss few more interesting topics, and we will dive deep into the more system design topics. These are the just fundamentals I'm teaching in this first and second lecture. I think in the from third to fourth, fifth lectures, you will get more interesting topics from this series. Thank you.